Okay, you're gonna find in Dry Lab 1, where you've got, and particularly Dry Lab 2, um, complex division and multiplication together. I'm gonna show you two ways to do that. Also want to talk about scientific notation in terms of your EE key on your calculator. Okay, you will see problems like this. Okay, so there's a combination of division and multiplication. Now, fractions are division. Fractions are division. So anything in the bottom is a division. Everything on top is multiplication. Even though there's a multiplication sign there. It's a multiplication sign of divisors, which means it's dividing. So the way to do this on your calculator, let me show you the two-part way, is to multiply 15 times 458, and that's going to be 8 times 12 is 96. So then people will then divide 687 0 by 96 to get their answer. That is one way to do it. And we've got two sig figs, so the answer is 72. Now, the problem with doing it this way is you're writing down a lot of numbers. So if you're dyslexic or partially dyslexic, there's a good chance you can write the wrong sequence down. Or just flat out, if you can't see worth a darn like me, you may not see the right one. The other way to do is totally internally within your calculator. So the way to do it in your calculator is to go 15 times 458, hit the divide key. 8, hit it again. 12, enter. So there's no writing down intermediate steps at all. Much more accurate, less prone for mistakes. So anything on the bottom, hit the divide key. Anything on top, you hit the multiply key. Yeah. That's right. I made a mistake. You learned from yesterday. So what should it be? 72 is two sig figs. So what's one sig, huh? 70, correct. I prove I'm human all the time. Okay, so it's very easy to do it this way. I've developed this technique a long time ago, and a number of teachers use it. It's not like I invented it. I observed it and been using it for decades. Most of my students have adopted it. It's not required though. So there's two ways to come to the same answer. Now, let's say this problem is worth 10 points. Well, usually on a story problem or a word problem, I give you 90% of the points are set up, 10% for the answer, like I was saying yesterday. This isn't really a problem, but let's say it was worth 10 points and you put down 72 like I did. What I would do is I would take off 1 point for not interpreting your sig figs. Okay, I wouldn't take off 10. So I usually do partial credit if you have something down. If you have nothing down or I can't follow your logic, which is most of the time that I don't give partial credit, I can give you partial credit. So if you miss the problem, I go back to your setup. If your setup is weird and I can't follow it, I don't give you any partial credit. Okay? All right. So let's do one with scientific notation now. Remember, scientific notation is in two parts. The first part is from 1 to 9. Actually, it's 9.9999. And the second part is an exponentiation base 10. Okay, so to do this problem, I'm going to do the same thing. Multiply everything on the top, divide by everything on the bottom. Now, again, there are two ways to do this. You can do it the two-step way. You write down your answer, or you let your calculator retain everything internally. Okay, so we're going to go 1.5. Now, this is the deviation on using the EE key. You can use the EE key in your calculator, which I highly recommend, or you can use your caret on your calculator. And I've never used this one up here. um, it's blinking. That's a good sign. Ah,
Calculator shit is basically if I do that, is it the same thing?
No,
Uh,
that's a natural occurring constant in nature. It's equal to 2.17.
hmm.
Now, let me, now you can download a TI-84 simulator.
Hmm.
That's free, but you want to use a scientific calculator. Okay. So in my calculator, I'm going to go 1.5 times 10 caret 3 times 458 divided by anything on the bottom, scientific notation wise, you have to put parentheses or you can use EE. So I'm going to use the parentheses route. Okay. So that's using parentheses. Now that's the old fashioned way of using scientific notation. This changed about 30 years ago. So instead of parentheses and carets and tens, we're going to use EE key. So we're going to go 1.5 EE3. No parentheses needed. The EE sticks the exponent and the number from 1 to 9 together. We don't need parentheses. So that's 3 steps eliminated. Times 458. Hit the divide key. 8 EE. Change sign. There's 2 negatives. One subtraction, one is change signs. They're totally different. The only time you use subtraction is when you're actually subtracting. If you want a negative number, you use the change sign. And then I'm going to do divide again by 1.2 EE4. I think I made a mistake on the top one. Okay, so. Okay, so you can see how EE saves you steps, yeah.
I think the change time.
Change sign is usually on the bottom, slightly to the
Oh,
right.
no. It's-
Okay. All right, so everyone try doing this and we all get the same answer. Now, are the sig figs right on this problem? That's right. They are not right. Okay. One sig fig. So the answer is 7 times 10 cubed. Now your calculator gives you all kinds of numbers. And usually you have to convert to the correct number of sig figs. Yeah,
Do you convert to the correct number of food foods like at the end, then?
good question. When do you convert? You always convert at the end. Otherwise, you may have rounding errors along the way. So yeah, do it at the end. Yeah, that's a good question. I should have mentioned that too. So, yeah,
We would do first, and then we would divide by the second bottom part. Okay,
by pressing the divide key. If there are two numbers on the bottom, you press the divide key for each one.
got
So if there's, now, in Dry Lab 2, we're gonna have problems that have like 5 or 6 steps,
it, okay.
and every one of them is a fraction, conversion fraction.
Okay, so I understand. 1.5 would be the first step. And then dividing by 8, the bottom part would be the second step.
You can do, division multiplication are, interchangeable.
Okay.
The order,
Got
so you can do, multiply, divide, multiply, or you can do all the multiplication, and then do all the
it.
division.
So it,
No, not at all.
Okay.
So what I tell people is just on the top, multiply, on the bottom, hit the divide key. And that's simpler than, your way would work fine as well, because of the operations of multiplication and division are interchangeable. That's called commutative. Yes,
Useful.
say again?
Can you just put a little? So for the first one, so the 71 at 5.6. How come you change it from going from 72 to 70? Like you're supposed to have, I don't know, you said it had one sig fig.
Yeah, because the 8 over here. Sig fig. That's why your answer's gonna have 1.
Does that mean you go by every time you like first number the.
Not the first number, the smallest sig fig. In this case, it was the first one, but usually it's not. It's usually scattered around. Just look at, go sig fig, sig fig, sig fig, and the smallest one, what your answer is gonna be. What would I,
Well, I'm just looking at the problems that,
which one?
look, just-
The bottom one?
so the EEs are, smallest one is, 3 significant figures, so would it be about like 2 other significant?
Well, this is one. That's one sig fig. Yeah, so scientific notation numbers, you don't look at the exponent at all, you just look at the number from 1 to 9. And whatever sig fig that is. Does that make sense?
Doing the software right now. Did I type that in correctly?
Yeah, did you push the, EE down there?
Yeah, you have to
Okay.
press the blue
Right,
and then,
Right, you have to do a shot. Yeah, then you hit the divide key.
oh, so I continue it before I press enter.
You don't have to be doing two steps. It's more accurate if you do it in one step though. So just continue. Everything on the top, you get the multiply key, which you did. Now you get the divide key and the stuff on the bottom. Which is the 8.
And the division thing.
Yep,
I agree with that.
which part?
That division 8.
That's EE.
Oh, yeah, and then 8, then you put in EE,
Yeah,
that's a minus?
and with the change sign,
No.
3.
Chain sign, which one is that?
Right here. That's change sign right here.
Ah,
Okay, this is subtraction, change sign. Totally different.
how do you know? I mean, it just looks like a subtraction sign, how can you tell the difference?
It's in parentheses.
All right,
And then over here, it's grouped with the division multiplication.
Yeah. right, I mean, that one doesn't have parentheses, so it's kind of confused.
There ain't parentheses if you use EE.
Oh, really? Okay, that's helpful.
Yeah, so you don't use, except I put the plus key rather than the minus key, and I don't know how to back up. Oh, it's like that. And then we're going to divide again. With 1.2 E4.
1.2 E squared?
Yeah. Oh, 1.2.
Right, so all I had to do was type in that problem. With those steps, and then it'll give me this.
That's 7.156 on 10 cubed, and then going 1 sig fig, it's 7 times 10 cubed. And you're gonna practice in the lab today,
Yeah,
a lot.
I'm looking forward to it. I'm actually looking forward to actually being standing.
Okay, are we all, yeah,
So is there one that you can just conversion on what you do on crap up here or on that later? So is that like the exponent?
super.
Sorry. So is the EE basically representing the exponent on like the top later?
Not only represents the times 10 to the exponent.
Oh.
Which is scientific notation. And lastly, the both come together. You know, now, when you're dividing by a scientific notation number, it's very important when you need more parentheses. Your end could be way. Yeah,
So can we do it either way?
yeah. It's one way, I think is less prone to error. When you're using the. But. It's one after the other. Okay, let's do another.
If you do this kind of like step by step, like each.
Yes, in fact, I'm gonna do little boxes which represent keys.
Okay, sorry.
You know, last semester over the summer, I was doing that. And a student asked me, where are the boxes on the calculator? So anyway, she understood after I explained, okay. I didn't want to do them 3-dimensionally. She was a wonderful student, an extremely OCD. So her notes were like out of a book. I mean, they were like, and she had bought the textbook 2 months before class started and read it all. Just to be prepared. Yeah, I know. Okay, so let's look at,
Yeah.
okay. By the way, we're gonna be using this number here, 602 times 10 to the 23rd. I mentioned it yesterday. We're using that number a lot in this class. Starting in unit 2. Particularly unit 2. Okay, so we got 108 times 10 to the minus 15. And I'm using parentheses now. 602 times 10 to the 23rd divided by 258 divided by 60 times 10 to the 4th. Okay, so the way we're gonna do this, I'm gonna do it by keys, yeah.
Is that a minus? Or
Number 15,
the 10? Yeah, before
the
that.
exponent is minus 15.
Ah, okay.
Okay, so. So you're gonna key that in. EE. Change sign. 15. Times. 602. EE. 23. Divided by 258. Divided by 6. Do I need to put the 0.0 in? No. When you're putting in your calculator, you don't need to put the 0.0 in. When you're calculating sig figs, you do, but not in the actual calculator. So you can put it in if you want, it will make no difference, but it's 2 extra key punches. Yeah,
So after 108, you put E there, is that just in place to be at?
no, that's a time multiplication.
Yeah, so it's substituted for the multiplication.
It is multiplication.
Yeah, okay.
So this is the first term, second term. First term on the bottom, we're gonna do the second term on the bottom. Okay, so that's all the keystrokes. Yeah,
Change buttons, to create the 15 to a negative. That is what we doing.
yeah, it's a change sign. So if you want a negative number, it's by default positive number. You want a negative number, you have to hit the change sign. But we want to subtract, use the other one. And the other one is grouped with the multiplication, division, addition, subtraction. Okay, how are we doing? All right, so let's see what this is then. That's 6.0, by the way. Okay, sig fig wise, we've got, 3, 3, 3, 2. So 42 is the answer.
Put zeros, two, so it's a-
It's 602.
This, no, there's a 6.0.
One on top is 6.02. Which one, which six you talking about? Bottom, okay. So say again your question.
It's like right in front. Wait.
Because trailing zeros count if there's a decimal point. And there's a decimal point there. Okay. Now, and you haven't had your drawing lab, right? You have lab today, right? Yeah, you're gonna be doing a lot of this zero stuff. I mean, lots of practice. So that's good news. All right, what do you guys think? Do you convert to EE? Yeah,
It's, so 6.0 and 6 are the same number,
as far as your calculus is concerned,
right? Why are they different as far as these two?
because it's a measure of precision. The 6.0 is more precise number than 6. It's just, if you were weighing it, for example, you'd go out 1 decimal place. 6, you wouldn't go out 1 decimal place, it'd be 0 places. So your calculator assumes it's 6.0 if you put nothing in. It automatically puts them in for you. But some people like to put it in anyway, just to be complete, which is fine, it's just more keystroke, that's all. Get the same answer though.
So. I'm so a little bit confused, because I just don't understand why not, like, make everything like, becomes like the same, like, you know what I'm saying?
Because it's not the same except the calculator. And the calculator just assumes, quite literally, there, if you put a 6 in, it quite assumes it's 28 point with 28 zeros after it. So that's 29 sig figs. When your number doesn't represent that, it's much less precise than that. Okay, so sig figs tells you how precise a number is. A lot of sig figs means it's precise. Few sig figs means it's imprecise. But as far as your calculator is concerned, it assumes everything is super precise. It's like a math kind of deal, mathematician kind of deal, not a real life scientist or an engineer.
Okay.
So my point is, you can add the 6.0 if you want, or 6.
Okay.
So calculator treats the 6 like 6.00 anyway.
Yeah.
A little better.
A little bit, yeah, I've taken like a lot of math classes, I haven't taken like any science classes, so I feel like I'm just like tripped out there because I'm thinking like. Yeah,
Well, I've taken a boatload of the nice math major. And until I got in science, though, in some engineering classes, I didn't distinguish between 6 and 6.0. But there is a big difference. Yeah. You go straight in. Yeah, so anything in the bottom hitting the divide key, everything on top you hit the times key. And when you switch over to the bottom, you just put the next number in, you don't have a space or nothing like that. Because if you put a space in the calculator, depends on the brand of the calculator, it will give you a syntax error. Okay, now this sounds like a math class. And it's the basics of doing problems. So when we get into unit 2, there's going to be chemistry versions of all this. So we can just focus on the chemistry part rather than the math and the chemistry part. So I always have to explain this for unit 1. Okay, any more questions about this problem? Yeah,
You know that carrot kernel you mentioned, was that in that?
no. Because we used E. If you didn't use the E with just parentheses, then you have to use caret. Good question. Yeah,
For lab one, you have to round up our answers, right? So.
no. There's a bunch of little problem sets. Each set has directions. Just
So for the lab one. Like 2.9, or maybe 4, or you, or we want like 1. Or wait.
I didn't follow your question.
Um. It's page here, so. I turned, 2.6 right into the 2.8, that was brown.
Okay, so you have two stick figs, two stick figs, two stick figs.
Yeah, so it would, it's a. Where is it on that?
Okay, you go to the third place, which is a 7. It's the 6 up to 1.
Oh, I did. Oh.
So if it's two sig figs, the here, sig figs, two sig figs, you go to the next one up, which is one word, you look stupid. And so that's the third significant, which is a 7. 5 and up, that takes the 6 up, 3 up. So, yeah. And if you're not by the drop, the multiplication, assign for you. And I'm fine with one. All right. Okay, one other thing, I mentioned this yesterday, mentioned at the beginning of class today. On sig figs, certain sig figs are by definition infinite. Like 12 in a dozen. It's exactly by definition. There's one other instance that it's infinite. Okay, now this is kind of difficult. Count. How many you got?
Right.
Exactly. Not 3.1, not 2.9, exactly 3. So that's also infinite. It's not one sig fig, it's infinite. So we have by definition and by counting.
Or technicality, technical. Right?
Sort of, yeah. All right, so that's what I wanted to cover today, math-wise. Now, dry lab 2, you're going to be doing a lot of word problems, like the whole dry lab is a set of word problems. And on Friday lecture, I'm going to focus on getting into word problems. And then we're going to have a little break. And then the next Friday, we're going to be getting into more of those word problems. I'm going to define, there's 3 kinds of word problems that you'll find in science. There's one involves fractions, one involves squared cubed, and one involves strictly linear. And you'll be working with examples of all 3 of those. So when we get to that, it'll make hopefully make a little more sense than what I just said. Okay, so any more questions about these calculations? Did everyone get the same answer I did? Okay. It's important that you get the same answer. That's what you'll be using your calculator a lot in dry lab 2. Okay, so let's go on to the next thing I wanted to talk about. Okay, for every wet lab, your first wet lab is lab 3. It's on density. All wet labs, no exceptions, require a pre-lab done before you enter the lab. Okay? It's worth 3 of the points of the 10 points. 3. It's very easy to do. You've got to handwrite it though. Everyone hates that, including me. I don't like to handwrite things. But the whole department is settled on this lab write-up, handwritten labs. Now, if you take 2A, some teachers don't follow this. They use a simplified kind of fill in the blanks for their lab write-up. Very unprofessional, and most of the teachers don't do that. Particularly 1A and 3A instructors. It's the 2As that vary. So mine, if you learn lab from me, it'll be very consistent with your next chemistry class. Okay. So there are 3 parts to the lab. Pre-lab, that's your ticket to do the lab. Actually doing the lab, collecting data, and then post-lab. Post-lab, you've got questions and a conclusion. Okay, so you need to pick up a thread-bound notebook like I mentioned earlier today. You can do a composition lined, or you can do one with grid in it. Now, the cheapest ones I've seen are, has anyone bought one yet? What'd you pay for it? 50 cents. Where? Walgreens, wow. That's the cheapest I've seen it. So it doesn't cost that much. And but it's got a hard cover back and front. And you're gonna number the pages. Top right, we're only gonna write on one side, not both sides. You have plenty of room in there, and the reason is sometimes your ink will bleed through. And since we have a lot of room anyway, and it also gives you the opportunity in the future, if you need extra space, you've got it there. Or if you run on both sides, you wouldn't have any extra space. Okay, so no wire spirals allowed. No 3-ring. It's got to be a thread-bound lab book. Okay, we're going to begin each lab on a new page. Yeah. Right, it's indelible. It's officially indelible, non-erasable. Now, some people do it in pencil, then they go over it afterwards in pen, which to me is huge, a huge amount of extra work. If you just start with, and I'll show you if you have an error, what to do about it. Okay. You can number the page on the top or the bottom. I don't really care. Most people do it on the top. All mistakes need to be readable. So if you're using a pen, what you would do is you would put a neat line through it so I can read the error and put the correction above or to the right. Okay, this is the part that's considered a pre-lab. Yeah. The right hand would be wrong, like part of the page, you cut through the correct path and go on the wrong that because you can see it back to someone credit. No, I just wouldn't give you a sad face. Some of this stuff is really picky, and that's picky, I think, is being too liberal. Because some teachers will make you, any white space left over the page, they will make you mark through it. So that it's totally consumed in writing. I know. In fact, universities do that more than community colleges do. In fact, at universities, you're given a lab book, which in graduate school, right? And it's university property. You don't own it. And it's for legal reasons in terms of doing during patents. Oh, yeah, it's real picky. I mean, picky. So, all right. So, but what you said is fine, as long as it makes sense and I can see also, do not rip out any pages, period. No exceptions. If you want to start over, just put a simple line through the page, go to the next page. Got plenty of paper. Okay, title of the lab. What lab are we doing? Density. Purpose of why we're doing it. Now, every lab write-up is going to have a background. That's where the purpose is found, and reading through the background. Why are we doing the lab? Understanding the difference between mass and volume, which is density. That would be a reason why we're doing the lab, both solid and liquid. Safety and first aid. Now, the first two labs we're using water and salt. First lab is water only, just pretty safe. Problem with water is if you don't get enough of it, you'll die.
If you get too much, you'll drown.
Too much, you'll die also, yes. Very fine line. Okay, so since we're not using a dangerous chemical on the first two labs, the second lab we use sand and salt and water. And it's table salt, so it's considered safe unless you take too much of it, particularly the sand. Don't eat the sand. And I'll show you how to get the SDS document for your chemical when we get to that part. Okay. Okay, I already mentioned you have to handwrite it. Data table. The purpose of a data table is a place to organize your data. So in your procedure, if it says observe, data table, calculate, data table, measure, data table. And all those are keywords as you need a place to put your data or the observation. Now, the data table I've written down here as part of the pre-lab, but I don't take off if you don't do the data table. You got to do it anyway, so you might as well do it in the pre-lab, and usually it doesn't take very long. Okay, sometimes there are pre-lab questions, not always. So if there are pre-lab questions, we'll do them. That'll be part of the pre-lab. Okay. Now again, I gave you a week to do all lab, wet and dry. So 3 parts again. Pre-lab is your ticket to do the lab. And what at the beginning of the lab, I'll run around and check everyone's pre-lab. Sometimes you get in a line and get it done, or at the end of the lecture, I can look at your pre-lab as long as I see it. I don't care, as long as it's before lab. The middle part of the lab, you actually do the lab. Like in the density lab, you'll be weighing some stuff. You'll be checking for volume and that stuff and writing down your data. And then the third part is doing the post-lab calculations and questions. And then write a conclusion. Now, conclusions, everyone freaks out about. I'm not expecting an encyclopedia. I'm expecting a paragraph. All you need to say is, what did you learn? And usually it relates to the purpose. That's all it is. Very simple to do. But all labs require it. Regardless if it says write a conclusion or to summarize. In this class, conclusion goes in every lab. Now, some labs in 1A, 2A, 3A will actually say summarize or words to that effect. And then other labs don't say anything and we don't need to do it. But in here, regardless, all labs require a conclusion. Okay. We're not going to be graphing into here, but if we did, I use the same presentation for all 3 of my classes, whether it's Chem A, 1A, 2A, 3A, 2B, the organic people do the same lab write-up. Sometimes you do a graph, sometimes you don't. If you do a graph, big graphs. Okay, so let's look at a lab. You get two signatures on the lab. The one on the right is for, did you do the pre-lab? And are you missing any parts to the pre-lab? The one on the left is for cleanup. Before you leave, make sure I sign off on your cleanup. Now, the first lab is really easy cleanup, because all we use is water. The second lab, we're using salt water. And so when salt water dries, you have a black countertop, it goes white, and it's really obvious that there's a deposit there. And it's because it's white, you don't know what it is. It could be sodium hydroxide, lye, or table salt. They look the same. They're both white powders. So it's important, and you take a damp paper towel, not wet, and you just quickly wipe it down. It takes all of 12.5 seconds to do. Okay, and that'll give you that other signature. Okay, so we've got a title. This is the oxygen content of air. It's a really good lab, and I don't know why they don't do it here, but they don't. But anyway, it's a good lab. Purpose, materials. I forgot to mention materials. Materials is just a simple list of stuff you're gonna be using. Like in density lab, you're gonna be using a block of material. Could be metal, wood, plastic. You're using water, using graduated cylinders. What else? The scale to weigh things. You just go through the procedure, and that's where you get the material. Yeah. Yeah, it's in your procedure, in your lab packet. All this stuff, except for the first aid. So at yours, where you work, do you have a station for SDS documents? Yeah.
Yeah.
And that's where you're gonna, in section 4 is first aid. Right, right. But my point is every store, pharmacy, whatever, has to have this document station by law. Because otherwise they're liable for lawsuit. And they have to tell you what chemicals you're exposed to and the first aid to treat it, how it's to be stored. So it's real important. OSHA tells you that in no uncertain terms. Okay, so materials. Procedure. Now, this is like a recipe for cooking, all it is. If you want to summarize it, fine. In fact, I like the fact if you summarize it because I know you read it. Now, you can do this whole thing, all procedure, and not read it, just copy it. So you can have no comprehension of what you're writing, or you can read it so it makes sense, because you have to read it sometime to do the lab. Now, you're going to be working with a lab partner, 1 or 2 lab partners, depending on the lab. So between the 2 of you, you're going to determine making sure that the procedure makes sense to both of you, as opposed to one person just looking on and the other person doing all the work. Now, some classes you're going to run into will have a lab practical. Anatomy, physiology as lab practicals. Microbiology, lab practicals. Frequently, Chem A, 1B, 5, 20, 12, 3A, 3B, not 2A. Those all have lab practicals. And basically is their stations and direction. You walk up to the station and you do what the directions say. Now, if you've been doing your labs, because it's all based on the labs you've been doing. If you've been doing the labs and you've been doing the labs yourself, you'll know what to do. If you haven't been doing them, you're not going to know what to do, and you'll do poorly on your lab practical. Okay, so that's basically it for pre-lab. Now, the write-up usually involve calculations. I calculate the density. Density is defined as mass over volume. So you calculate the density of, say, sand as opposed to lead, whatever. It's just mass over volume. This is another lab that as example. Now, when I copied this, we're using Canvas. So they actually had to turn in the lab to me. As opposed to uploading in a Canvas. All labs, dry and wet, are gonna be scanned. With a scanner on your phone, convert it to a PDF file, and then when you click on the assignment for that lab, it'll prompt you for a file. And that's the PDF file that you created. Okay? So if it's a wet lab, you're gonna be scanning your lab book. If it's a dry lab, you're gonna be scanning the packet, lab packet worksheet. Okay, does that make sense? On your phone, you have a scanner. There are lots of free ones, don't pay for them. That's only for Apple phones, not for Android. And it works okay. The problem is it doesn't keep the file. Or if you use a separate scanner, you actually save the file on your phone. You can send it to your email or whatever. But yeah,
But also. They scan.
yeah, most scanning apps can do that. It's a function of the app, not the phone. But with Canvas, it's built into Canvas. And I don't know why they didn't implement it on Android. It's just easy. Sometimes we have a bias in the community. Okay, so this would be what a first aid would look like, for example, for hydrochloric acid. And I don't believe in busy work. Hate it. So when you're doing safety for a chemical, and the first aid is the same, don't repeat it. Just put 2 chemicals at the top, like hydrochloric acid and nitric acid. Probably have the same first aid. So don't do one for nitric acid and one for hydrochloric acid, do a combo. Also, in lab 10, if we're using hydrochloric acid, and we use that in lab 3, just say C lab 3. Yeah, I want you to be exposed to the first aid, but no busy work. You have enough busy work in your life, even though digital, you're supposed to save that, but
And
Oh.
the
Huh?
first aid is also in the kit or the.
no, gotta look it up, SDS. And there's an SDS station in the lab. You can do it in lab without having to look it up if you want. Either way, it's fine. I just want you to be exposed to the first aid. Okay, this is what a data table looks like. All numbers need units except for pH. And there may be a couple more, but pH is the most common one without unit. We're gonna mention pH at the unit 3. Very briefly. It's out of the scope of this class, but I mentioned it anyway, just because it's so common. Who's not heard of pH? A pH is a measure of acidity.
Oh, pH, like the thing in water.
Yeah, exactly. Yeah, it's like little p, big H. And the definition of that is the negative logarithm of the hydrogen ion concentration. You get all that?
50%.
The P number is used a lot in science. There's POH, pH. It's used in carbohydrate chemistry, blood sugar levels. They use it a lot in that. So it's used. It's an easy way to handle very small numbers. And acids in our body, for example, are very dilute versions, and they're also weak acids, not strong acids, except for our stomach. Okay, typical data table. Put a 0 before the decimal point, units on numbers. And the data tables can all look different too. As long as there's an organized place, put your data. Doesn't matter. Okay, example of a list of materials. More data table. It used to be called, instead of SDS, it used to be called MSDS. And they changed it to SDS, and I don't know why. MSDS sounds like Spanish. Okay, here's an example of an error. Very simple line through it. Okay, so that's basically the write-up. The first lab is a real easy, oh, and one other thing. On lab write-ups, your first lab, you can screw it up totally and you can correct everything. Because you never had a lab from me before, you've never written up a lab from me before. After that, you get what you get. So the first lab, everyone should get a 10 out of 10, unless they want a 6 out of 10 or 4 out of 10. You can get that. But everyone should get a 10 out of 10. Okay, so basically, if you did something wrong, show it to me again and I'll correct it online for you. Now, I like giving points to students. I like when my students succeed. That's why I try to give you all the little tricks along the way. I want you to do well. Because then when you do well in this class, you'll do well in your next chemistry class. And a lot of teachers give me compliments on how my students do in their class. I taught a summer 1A class, and I had 50 students, and most of them were retakes from other schools. We had the University of North Dakota, a lot of Davis, a lot of Sac State, and they're all there because they flunked 1A. Except for 6 of my Chem A students. Guess who got the A's? My Chem A students. Those other students, a lot of them got C's and D's. And they were very unhappy. I said, your setups are non-existent. They just write an answer. Or they don't study, you know. Summer school is hard taking math or science in the summer. And some of my students last summer semester, were taking 3 classes. 3 classes, including my Chem A class. I could not believe it. And they were always complaining about how much work they have to do. Well, duh. Taking 3 classes in the summer. Anyway, all right, that's what I wanted to cover today. Are there any questions about either the lab write-up or pre-lab or? Yeah. Has to be printed. Now, if you're using it on a tablet or your laptop, it still has to be printed. No. I'm not sure I'm following. What?
Procedure part.
Huh?
She was asking if it could be like cursive writing.
Oh, okay. Yeah,
You want it in.
cursive is fine.
Oh.
As long as I can read the cursive. Another thing too, if you speak another language better than English, and you like to do the procedure and purpose in like Spanish, for example, that's fine with me. It doesn't have to be in English. Now when you answer the questions, it has to be in English, because my Spanish is. And that's the only language I really know other than English. I know a little bit of Croatian, because my first wife's grandmother spoke Croatian, so she taught me a little bit. I know a little bit of Russian, but not very much. I would be in bad shape if you threw me in one of those countries. Yeah.
So would it just be preferred that we have like a labs, like lab stuff, like in tablet or use like after?
Most people keep it separate. Some people though, they'll take notes on the back going this way, and then the labs are going this way. So does that make sense? Yeah, and usually they do okay. I think they run out of space though towards the end of the semester, unless they have a big lab book. But just spend another 50 cents to know the lab book. So, all right. Anything else? Okay, so I'm gonna, break all this down and I'll meet you in the lab. If the lab is open, go ahead and go in here. We're gonna be doing lab 1, so you can get that out. Also, one other thing before you go, think about a lab partner. Your first wet lab, you need a lab partner. Okay, so if your friend is in class, great, or if you sit next to someone and you're getting along, ask them if they can be your lab partner.
We're supposed to. I'm doing it in this way. Or, because I said you did it's faster to get fired when I go over the urgent studies. Yeah. I think it's so long ago, so maybe.
Yeah, but then we're not.
Okay.
For a couple of weeks. You don't, I mean, you're gonna be scanning this, nothing other than it's on if you can. You can't know who you are. If you want to name, it's fine.
So I'm supposed to be doing this.
Yes, and then you're going to be, scanning this,
That makes a lot more sense.
and creating a PDF file.
Make sure I'm not getting it. I think I got used to this thing. And when is this due?
Those are. So we think. Yeah, so we get plenty.
Yeah, I. If not, this, I cannot put the guys from doing it, but.
I don't know how the other kids are taught. I mean, all my classes. Doesn't matter what time. Okay, or. It's really easy. Okay.
Yeah, definitely is.
Yeah, this looks fine. It's legible and it's good.
Where is this changes?
Oh, yeah, it's fine.
Okay.
If you got a either, not only shake or anything, that's fine. But one other thing, let me show you something. All it is, allow you to switch back between scientific and floating point. Let's say we have 5.36. That number. This is. And one of that is scientific notation, see the psi there? And shift psi, scientific notation. And then to go back, the FLO stands for floating
So
point,
would you shift it again and then,
and go flow, comes back.
thank you.
What did that cost?
I don't know if the books, the big store, I could check.
Oh, that's okay. Is it like? Look.
Yeah, it wasn't
Yeah,
expensive.
It's. So I wasn't able to print the lab. So I'm wondering if you could, so I was having issues.
I have it digitally, I don't have it paper. So, are you on Canvas?
Yeah.
Okay, on Canvas, let me show you.